All right, for today's lesson, you're going to get the sheet that says writing numbers in scientific notation. Okay, so scientific notation is just a special way that we represent very large numbers or very small numbers. It doesn't really, I guess it's not really productive to write out a number such as like how many miles it is from here to Jupiter. It'd be an extremely large number. So they would write that in scientific notation, or perhaps the atomic weight of a single molecule, be very, very tiny. So instead of writing out that very small number, they can represent it in a number that is more manageable, and that's what we call scientific notation. So in scientific notation, there's some basics that we have to have. And the first thing is you have to have a base number. Okay, the base number has to be one or more, but less than 10. Okay, so your base number is a number. It's got to be one or more. It can be one, but it can't be less than one. And you can go all the way up to 9.99999, but it can't actually reach 10. All right, and then scientific notation always has times 10 to some power, okay, raised to some exponent. So let's see what we're talking about here. On number one, I look at this number and I ask myself, is it one or more? Well, 0.617 is not one or more. It's definitely less than. So what I want to do is I want to identify where the current decimal is. I put my pencil on the decimal, and I need to ask myself, which direction does it have to move? So this is going to have to move to the right, and it's going to move to the right to make my number larger. And now it's at between the 6 and the 1. So I ask myself, what's that new number? And that is 6.17. Well, 6.17 is more than 1, and it is less than 10. So I'm going to stop there, because if I moved it one more, you'd be at 61.7, and that'd be way too large. So I'm going to write down my new base number, kind of cleaned up without the squiggles, and my new decimal spot. So 6.17. And then you always add times 10. That goes on. This piece goes on automatically. Okay, if you're moving your decimal to the right, it's going to be a negative exponent. And this is kind of backwards thinking to what you're used to. But if that decimal point has to move to the right, then it results in a negative exponent. So my exponent is going to be a negative, and the exponent is the number of movements you had to move that. So it only went one time. So my final answer is 6.17 times 10 to the negative first power. Okay, let's look at number two. So number two we see again is a very tiny number. So I'm going to identify where the decimal point is, put my pencil there, and then yes, it has to move to the right. So I'm going to move it, and it's got to be moved more than once, because if I move it once, that's now 0.0276, still too small. Move it one more, that's 0.276, not big enough. Move it one more. Now we're at 2.76, and that works because it's one or more. It is less than 10. So I'm going to stop there. I'm going to rewrite my new number, 2.76. I slap on the times 10, and then I'm moving to the right. So therefore my decimal or my exponent is going to be a negative. And I moved once, twice, three times. So it's to the negative third power. So that's 2.76 times 10 to the negative third power. Okay, number three, we see a number now that is larger than 10. So what I want to do is again identify where my current decimal point is. Well, you don't see one here, so you know it's located behind it. So I'm going to go ahead and put that decimal point behind there. And in this case, the decimal has to start moving to the left. So we want a number that's one or more, which this is, but it needs to be less than 10. So I move it once, I'm at 400, still too large. Move it, you're at 40, too big. Move it one more, and it's between the 4 and the 0. and that's fine. So that gives you 4.000, but I'm not going to bother writing down all those zeros. I'm just going to say 4, or that's 4.0. However, if you want to put that 0.0, that's fine. If you don't want to include that, that's okay too. Now, we put times 10 on there, and if your decimal point is going the opposite direction from what we did up here, well, that's going to be a positive exponent. So that's 4 times 10. I moved it once, twice, 3, so to the third power. Okay, number 4. Again, I don't see a decimal point, so I'm going to go ahead and put it at the very end. 961 is way larger than 10, so I'm going to start moving it. You're at 96.1. Now we're at 9.61. So 9.61 is 1 or more. It is less than 10, so we're going to stick with that. So I'm going to rewrite 9.61. Again, you always put on the times 10, and then we moved it 2 times, so it's to the second power. Okay, number 5 now, we see this term coming up, standard notation. Well, standard notation is the opposite of what we've been doing. Standard notation is taking numbers that were in scientific notation and then writing out just the large number. Either it's a very big number or a very small number. So we're just kind of undoing what we did. All right, so how I'd approach this. I start off with the base number. I'm going to write down the base number with the decimal, 4.7. And it has a negative exponent, times 10 to the negative first power. Okay, so it is backwards from what we did before. If you have a negative exponent, your number has to get smaller. So a negative exponent means this is going to move to the left. And it's going to move however many times it says. So there's 1. Okay, so it's going to move 1 time to the left. And there's my new decimal point. We don't leave our answers like that. We do need to clean it up without all the squiggles. So we have a new answer of 0.47. Okay, number 6. Again, I'm going to write down the base number, 4.2. Identify where the decimal point is. Look at your exponent. Your exponent's a negative, so this decimal point's going to move to the left. And it's going to move once, twice, because of that exponent being a negative 2 there. I have a blank, and we fill the blanks in with zeros. And then I need to rewrite it, clean it up. So we have 0.042. Okay, number 7. Again, write out the base number, 8.6. This time we got a positive exponent. So positive exponent, instead of moving to the left, you're now going to move to the right because our number has to get larger. So here's my decimal. I'm going to move once, twice, because of that exponent 2. There's the new decimal spot. Fill the blank in with the 0, and then we clean it up. So it's just going to be 860. Technically, the decimal point's behind, but you don't have to write that there. You just write 860. Okay, number 8, we have 6.8 times 10 squared. So let's write down 6.8. And then identify where your decimal is. Check out the exponent being a 2. It's positive. So again, it's going to move 2 spots to the right. We are going to fill in with the 0. And then we get 680. Okay, with that, you guys